Hey there everyone, Ramesh here. Welcome to Java Collections Framework course. In this course, you are going to learn the fundamentals of Java Collections Framework, and you will also learn the important Java Collections Framework interfaces and classes. Okay, so this course is very useful for beginners who want to learn Java Collections Framework with lots of examples. So in this course, I have demonstrated the commonly used collections framework interfaces and classes with lots of coding examples. And in this course, we mainly focus on coding examples rather than theory. So I prefer explaining each and every concept with an example. So in this course, we are going to learn collections framework with lots of coding examples, and we're going to use Eclipse IDE to develop all the examples about collections framework. So we'll begin with what is the need of collections framework, okay, and what is the advantage of collections framework over an array. So once we'll understood what is the need of collections framework, then we'll deep dive into the collections framework important interfaces and classes. All right, without further ado, let's get started. So before deep dive into the collections framework, let's first understand what is need of collections framework. Okay, so whenever you plan to learn any framework or any technology, first you should need to understand what is need or what is the purpose of that particular framework or technology. Okay, similarly we are going to explore Java collections framework in this series. So let's first understand what is the need or purpose of collections framework and what problem the Java collections framework solves. All right, great. So I always prefer explaining concepts with an example. So let me switch to the Eclipse IDE and let me create a new Java project, and let me create an example to demonstrate why we need a collections framework. Alright guys, let's switch to the Eclipse IDE. I am in Eclipse IDE and I am going to create a new Java project. Go to the file, new, and then choose Java project, and let's give name to the project like Java collections framework, something like this, and hit finish button. Well, we have created a simple Java project. Within a Java project, let's go ahead and let's create a package. Let's call it as com.java.collections. Okay, right click on the package, new, and then choose class, and let's give a name to the class like need of collection, something like this, and choose public static void main method and hit finish button. All right, now let's create a integer variable int a equals to 10. So this is how we store an integer number in an integer variable in Java. Okay, so let's say I want to store one more integer number 20. Then what I need to do is I need to create an integer variable int b equals to 20. All right, so let's say I want to store one more integer variable, that is 30. Then what I need to do is I need to create an integer variable int c equals to 30. Okay, so let's say I want to store 10 integer numbers, then I need to create a 10 integer variables. Okay, something like this. All right, and I need to give a name to each integer variable like d, e, f, g, h, something like this. All right, so this is how we store integer numbers in individual integer variables. So let's say I want to store 10,000 integer numbers in integer variables. Alright, so then what I need to do is I need to create 10,000 integer variables. Alright, so this is a worst programming technique. So create, having 10,000 integer variables in a Java program, it's kind of worst programming technique. I would say it's not a good programming practice. All right, and yeah, so overcome to this problem, we have a concept in Java called arrays. Okay, array is a data structure which can hold homogeneous data elements. It means we can store a similar type of data elements. Okay, for example, let's say in our example I can create a array of integers, something like this, equals to new int, and I can define a size of an array of integers like 10,000. Okay, all right, so the main advantage of array is that we can store multiple values with a single variable. So instead of creating a separate variable to represent a value like this, so we can use array to store multiple values with a single variable like this. So now we have created and declared an array with size 10,000. So we can store a 10,000 integer values in this single variable. Okay, so this is the main advantage of array. Array is index collection which holds homogeneous data elements, and arrays are fixed in size. So once we create an array, there is no chance to increasing or decreasing the size of an array as per our requirement. Well, if I create an array with size 10,000, something like this, then let's say I want to store 20,000 elements in an array. It's not possible to change the size of an array later. So whenever we create an array with some size, there is no chance of increasing or decreasing the size of an array as per our requirement. All right, so this is the main disadvantage of an array, or we can say it's the main limitation of an array. Well, let me write the comments over here. Limitations of an array. Okay, so first limitation is arrays are fixed in size. Okay, so once we create an array with some size, there is no chance of increasing or decreasing the size of an array as per our requirement. So this is the first limitation. The second limitation is that array can hold only homogeneous data elements. It means we can store only similar type of elements, data elements in an array. It's not possible to store different types of objects or elements in an array. Okay, so second limitation of array is that arrays can hold only homogeneous data elements. Okay, for example, let me demonstrate this point. Let me quickly create a class called student, and let me create one more class called book. Okay, now what I will do, I will create array of students. Okay, students equals to new student. Okay, and I will declare a size of an array of students like 10. So remember, arrays are objects in Java, and we can use new keyword to create an object of an array. Okay, so this is how we create an array in Java. Now I want to store an element in this array. So what I need to do is I need to add an element to zeroth index of an array, something like this, new student. Okay, and also I can add another student at index 1 of this array. And if I try to add a different type of object like book, so this must give a compile time error, that is type mismatch error. Okay, cannot convert from book to student, because arrays can hold only homogeneous data elements. It means it can hold only similar type of elements. We cannot store different type of elements in an array. Okay, understood? So this is the limitation of an array. Okay, and in array we have a solution for this limitation. So we can use array of objects to store a different types of elements. For example, we have a object class, right? So object class is a super class of all the classes, so it can hold different type of objects. Well, let me create object of an array like this. Objects equals to new and then object, and declare a size like this. Okay, so if you try to add different type of objects to an array of objects, it is possible. Let me quickly do that. Okay, so look at here, I have created array of objects and I have added student object to an array, that is objects at index 0, and I have added one more student object at index 1, and different object like book is added to index 2 of an array. Alright guys, we can add a different type of objects to an array of objects like this. Okay, so this solves the limitation of an array that holds only homogeneous data elements. Now let's understand the one more important limitations of an array, that is array concept is not implemented using any standard data structures. Hence, array does not provide any ready-made APIs or methods as per our requirement. So whenever we want to write some logic to implement algorithm or data structure, we have to explicitly write the code in arrays. Okay, there is no ready-made APIs are available to to write the logic for algorithms or data structures in array. Okay, so this is one more limitation of an array. Okay, so ready-made support is not available in array. Okay, great. This is the third limitation, right? Yeah. So these are the three major limitations of an array, and overcome to these limitations we have a collections framework. Okay, so collections framework are introduced in JDK 1.2 release, and collection framework solves all the limitations of an array. Hence we need a collection framework. Understood? Why do we need a collection framework? So overcome to the limitations of an array, we need a collections framework to solve all the limitations of an array. Okay, so arrays are fixed in size, arrays can hold only homogeneous data elements, and arrays do not provide a ready-made APIs to work with data structures or algorithms. Okay, and collections are growable in nature. So for example, ArrayList. So ArrayList it internally uses dynamic array, so it can increase or decrease the size as per our requirement. So this way ArrayList can solve the problem. Okay, and we can store different types of objects in collections. For example, we can store a string or integer. Okay, we can store both homogeneous and heterogeneous data elements in a collections. And yeah, so collections framework is implemented using standard data structures Alright, and there are a lot of ready-made APIs are available, so we no need to write explicitly any APIs or methods to work with data structures or algorithms in collections framework. So in this way, we can reduce a lot of programming effort by using collections framework. Okay, so all these limitations are solved by collections framework, which is introduced in JDK 1.2 release. Okay, great. Alright guys, I hope you understood the need of collections framework. Well, a collection is a group of individual objects as a single unit. Let's say we have a student 1, student 2, student 3. So these are the group of student objects, right? So collection represents these group of individual student objects as a single unit. Let's take one more example. Let's say we have employee 1 and employee 2, employee 3, and so on. So these are the group of individual employee objects, right? And collection represents these individual employee objects as a single entity or single unit. So this is what the collection. And collection framework, it defines several classes and interfaces which we can use to represent a group of individual objects as a single entity. Now let's take a look at Java collections framework hierarchy. So first we have a collection. So collection is basically a root interface in Java collections framework hierarchy. And we have a list, queue, and set. So these are the sub interfaces of collection interface. And list, queue, set. So these are the interfaces which extends a collection interface. And look at here. Here we have ArrayList, LinkedList, vector, and stack. So these are the concrete implementation of list interface. Alright, so these are the commonly used implementation of list interface. And here we have a set implementations like HashSet and linked HashSet. So these are the two commonly used implementation of set interface. And here we have sorted set interface. So this is the purpose of sorting the elements in ascending or descending order. So here we have tree set class which implements sorted set interface. And here we have queue interface. It has several implementations, like priority queue is the common implementation of queue interface. And here we have dequeue interface which extends queue interface. And here we have array dequeue implementation class which implements dequeue interface. So alright guys, these are the commonly used interfaces and their implementation classes. And we have map hierarchy. Let's take a look into the map hierarchy separately. So we have map interface. It contains key value pair, and there are many commonly used map implementation classes, like HashMap is the most commonly used class which implements map interface. And we have linked HashMap and hash table. So hash table is a legacy class in collections framework hierarchy. And we have sorted map. So the purpose of sorted map is to sort map keys and values. And we have tree map class which implements sorted map. So this is the commonly used map hierarchy, guys. Now we theoretically understood the collections framework hierarchy. Now let's see how the collections framework hierarchy is implemented in actual core Java packages in action. Let's go to the Eclipse IDE, and we have created Java collections framework project in one of the previous video, and this is the GRE system library which is associated with this project. And expand GRE system library, and within a GRE system library you can find rt.jar file. So rt.jar file, it located inside a gre/lib folder. Alright, and rt.jar file contains all the core Java packages. And remember, Java collection interfaces and classes are located inside a java.util package. Let's go ahead and let's search for java.util package here. Yeah, here we go. So this is a java.util package. So look at here, inside java.util package you can see .class files. So in order to view the source code of .class files, you need to install decompiler in Eclipse IDE. So I have already installed decompiler in Eclipse IDE so that I can able to see the source code of .class files. So in order to install decompiler in Eclipse IDE, go to the help and go to the Eclipse market and just search for decompiler, and you can install decompiler in Eclipse IDE so that you can able to view the source code of .class files. Alright, great. Within a java.util package, let's search for collection interface. So collection interface is a root interface in Java collections framework hierarchy. Alright, and it internally extends iterable interface, which is for the purpose of iterating over a collection of objects. Alright, and collection interface has many child interfaces, right? So let's search for one of the child interface, that is list interface. So this is a list interface, and list interface extends a collection interface. Okay, so if you look at the collection framework hierarchy, list interface extends a collection interface, and we are looking this same hierarchy in action in actual source code of core Java packages here. List interface extends a collection interface, and list interface has several implementation classes. Right click on list interface and open type hierarchy. Here you can see different classes are implementing a list interface. For example, ArrayList class. So ArrayList class extends abstract list, which implements all the common methods, and ArrayList class implements a list interface, and it also implements a different interfaces like serializable, clonable, random access, etc. Okay, and look at here, the default capacity of ArrayList is 10, and we'll learn more about ArrayList in further videos. And we have linked list class, which implements list interface, and linked list basically internally uses a doubly linked list for the implementation. Alright, and again we have different implementations like vector implements list interface, and we have also stack. Now this completes list interface and its classes. Now let's go for set interface. Let's search for set interface here. So this is the set interface, which internally extends a collection interface, and set interface has several implementation classes. Let's see what are the implementation classes. Right click and open type hierarchy. So look at here, HashSet is a class which implements set interface, and we have linked HashSet, which again implements set interface. So these are the common concrete classes which implements set interface, and sorted set is interface which extends set interface, and sorted set has an implementation class, that is tree set. So that we can see by right click on this interface and open type hierarchy, and here you can see a tree set. Okay, so tree set internally implements navigable set, and navigable set internally extends sorted set. Okay, great. Now let's search for queue interface. So look at here, queue interface internally extends collection interface, and queue interface has implementation classes. For example, let's search for its type. So look at here, dequeue interface extends a queue interface, and dequeue interface has several implementation classes like array dequeue, okay, and linked list. And queue interface has an implementation class like priority queue. Okay, so look at here, queue interface has an implementation class, that is priority queue, and dequeue interface extends queue interface, and ArrayDQ implements a DQ interface. So this is the hierarchy. So we have seen the hierarchy of collection in actual jar file. Let's also look at the map hierarchy in a source code. Now let's search for map interface in java.util package. So look at here, map interface, it stores key value pair and it does not extend collection interface. So look at here, here are different implementation classes like HashMap, HashTable. So these are the classes which implements a map interface, and we have a linked HashMap which implements map interface. And look at here, sorted map, which is the purpose of sorting keys and values of map, and it has an implementation like tree map. So this is all about the map hierarchy in actual core Java packages, that is java.util package. Alright guys, we have seen what is a collection, what is a collections framework and collection framework hierarchy, and we also looked into the actual interfaces and classes of Java collections framework in a core Java package, that is java.util package. So if you look at the collections hierarchy, collection interface sits at the top of the collections hierarchy. Okay, and in general, collection interface is considered as root interface of the collections hierarchy. So collection represents a group of objects called its elements. For example, let's say we have a collection, it has group of objects like object 1, object 2, object 3, and so on. So collection represents a group of individual objects as a single entity. Okay, great. And when should we go for collection interface? So if we want to represent a group of individual objects as a single entity, then we should go for collection interface. Okay, so whenever we want to represent a group of individual objects as a single entity, then we can go for collection interface. Alright, great. And collection interface defines all the common methods that are applicable to all the collection classes in the collections hierarchy. For example, collection interface has all the common methods that are applicable to list, queue, set, dequeue, sorted set, and their implementations, etc. We will deep dive into the collection interface. So basically we are going to explore where basically collection interface is present, in which package it is present, and in which jar file it is present, and we'll explore all the methods of collection interface and what are the newly methods are added in Java 8 to collection interface. Okay, let's go ahead and let's switch to the Eclipse IDE. So in Eclipse IDE you first need to install decompiler. So we are going to decompile .class files in Eclipse. So in order to install decompiler, you can go to the help section and go to the Eclipse marketplace, and in a find you can just search for decompiler. Okay, and hit go button and look at here, enhanced class decompiler 3.1.1. so this is the decompiler you can install in your Eclipse. So I have already installed it, that's why I can get this label installed. Okay, once you have installed decompiler successfully in Eclipse, you can able to decompile .class files. So let's explore where collection interface present, in which package and in which jar file it is present. For that, so this was the project we have created in previous videos, right? So this is a JRE system library and I am using Java 1.8. so click on expand JRE system library and you can see here bunch of jar files. This is a rt.jar file, so let's expand this rt.jar file. Inside this jar file you can see a lot of packages. Okay, so let's find java.util package inside this jar file. Let's scroll down and go to the java.util package. Okay, so collection interface present inside java.util package. Let's expand java.util package, and here we go. So this is a collection.class. So this is the interface that we are going to explore. So let's double click on it, and you can able to see the source code of collection interface. Okay, so if you are installed decompiler successfully in Eclipse IDE, then you can able to see the source code of collection interface like this. Okay, so we have seen that collection interface is a root interface in collection hierarchy, and collection represents a group of objects known as elements. Alright, so look at here, collection interface is a generic interface, so you can pass any type to the collection interface, and collection interface extends iterable interface. So we can use a iterator to iterate over collections. So for that it internally extends iterable interface. Okay, so look at here, a collection interface provides a common methods or APIs that are applicable to all the collections in collections framework. For example, size. So size method returns a number of elements in the collection, and isEmpty method returns true if the collection contains no elements, and contains method returns true if the collection contains any specified element. Similarly, you can use iterator to iterate over a collection of objects, and toArray method to convert collection into array. Okay, and we can use add method to add a new element to an existing collection, and we can remove element from a collection using remove method, and we can use add all method to add a collection to the existing collection, and we can use a remove all method to remove a collection from existing collection. Okay, so these are the bulk operations or bulk methods. Okay, and apart from that, so look at here, default method. So Java 8 onwards we can able to see default and static methods. So in Java 8 default methods are added to the collection interface, that is remove if method, and this method takes predicate function interface. Okay, and we can pass a lambda expression, and we can use if remove if method to just add a condition. If element is present, then only we can remove that element from the collection, something like that. And you can use retain all clear method equals hash code and splitter. So Java 8 onwards we can able to use splitter method. So Java 8 provides feature like we can add a default and static method, right? So these are the default methods added in Java 8, that is stream, parallel stream. Alright guys, these are the common methods that are added to collection interface. Alright, this is pretty much about internal source code of collection interface. Okay, let's go ahead and let's understand more about collection interface with an example. So JDK don't have direct implementation of collection interface, but list interface extends collection interface, and list interface has multiple implementation classes like ArrayList, LinkedList, vector, and stack. So we can use one of the implementation class to create a collection interface object. Okay, let's go ahead and let's use ArrayList class to create object of the collection. Let me switch to the Eclipse IDE. In Eclipse we have a Java Collections Framework project, and let me create a new package inside this project, and let me call it as interfaces. And inside this package let me quickly create a class, and let's name it as collection demo, and also choose public void main method and hit finish button. Alright, Let's go ahead and let's create an object of collection. So make sure that you choose collection from java.util package, and let's pass a type as string, and let's say collection equals to new, and then we can use ArrayList class to create a collection object. Now we have created collection object. Let's go ahead and let's add few elements to the collection. For example, collection dot add. So we can use add API to add a new element to the collection. Let's say I'm going to add something like, let's say banana. Okay, and let's rename this collection like let's say fruit collection, something like that, fruit collection. Okay, let me add one more fruit to the collection. Fruit collection dot call add method, and then let's add apple to the collection, and let's go ahead and let's add one more fruit, let's say mango. Alright, so this is how we can use add method to add a new element to the collection. Now if you want to remove any of the element from the collection, we can use a remove method. So let's go ahead and let's pass an element name to the remove method. Let's say I want to remove banana from the collection, so I can simply call a remove method. Okay, let me put a sys out here, and let me print this collection, and after removing an element from the collection also I will put the sys out. So let's go ahead and let's run the program, and let's see how it works. Yeah, here we go. So this is how we got a result when we add all the new elements to the collection, and after that we have removed a banana element from the collection, and we have printed the collection, and look at here the result, banana element is removed from the collection. Alright guys, so let's say I want to check whether a particular element is present in a collection or not. For that I'm going to use contains, and let me check apple element is present in a collection. So contains method returns a boolean value, either true or false. If this element contains if this element is present in a collection, then it returns true, otherwise it returns false. So let me print the result to the console so that we'll able to track the result. Yeah, here we go. So apple element is present in a collection, so contains method returns true, and that we have printed on a console. Alright, so let me use few more methods, like let's say fruit collection dot. So look at here, there are a lot of APIs. So these are the APIs or methods which are common for all the collections in collections framework. Okay, and you can see here you can use isEmpty method to check whether a collection is empty or not, and you can use iterator method to iterate over a collections objects, and you can use a remove all method to remove a bulk, bulk objects, and you can use for each method to iterate over a collection. So for each method is introduced in Java 8, so we can use for each method to iterate over a collection. So, and for each method accepts lambda expressions implementation. So for each method basically internally uses a functional interface called consumer. So consumer is a functional interface, so we have to use a lambda expression to implement a consumer interface. Okay, so let me use a lambda expression here, and this accepts a parameter, and then arrow syntax, and this is a sys out here, and just print a element to the console. It's pretty simple, right? Let me run the program and let's see how it works. Yeah, here we go. Okay, the list has apple and mango elements. Alright guys, you can explore all the methods of this collection interface. For example, if you see here, it provides other methods, like you can use clear method to clear the collection, contains all method to check multiple elements are present in a collection or not. You can use iterator to iterate over a collection, and you can use a stream method to work with the streams. Alright, so there are other APIs. You can take these methods as exercise and you can just create an example and play with all these methods. Okay, I'm going to call a clear method to clear the collection, and after that if I print this collection, then there is no more elements present in a collection. Okay, so look at here, the collection is empty. Alright guys, let me summarize what we have learned about collection interface. So collection interface is a root interface of the collections hierarchy, and whenever we want to represent a group of individual objects as a single unit or entity, then we can go for collection. Okay, and so collection interface don't have direct implementations, but list, queue, set and other interfaces extends collection interface, so we can use their implementation classes to create a collection object like we have seen in an example. Okay, great. And collection interface provides all the common methods that are applicable to other interfaces that extends collection interface. Okay. List is an ordered collection. It maintains the insertion order, which means upon displaying the list content, it will display the elements in the same order in which they got inserted into list. Okay, so list is a ordered collection. It is also called a sequence, and it maintains the insertion order. Okay, and list provides a control over the position where you can insert an element. So list basically has an index. Okay, and list index starts from 0, just like arrays, and you can access elements by their index and also search elements in the list. So list has indexes, so we can access elements from the list by using their index, and list allows you to add duplicate elements, and also list allows you to have a null elements. Okay, and some of the most popular list implementation classes are ArrayList, LinkedList, vector, stack, copy and write ArrayList. Okay, list interface extends collection interface, and list interface has common implementation classes like ArrayList, LinkedList, vector and stack. Alright, so you can use either of these classes to implement list interface, and here we have a choice. Okay, so based on the requirement we can use any of these classes. Okay, great. So let me demonstrate these points with an example. So let me switch to the Eclipse IDE and let's see whether a list allows us to add duplicate elements or not, list allows us to add null elements or not, and list starts with index 0. Alright, so let's understand more about list interface with an example. So let's go ahead and let's create a new class and let's call it as list demo. Okay, and quickly create a main method and quickly create a list object. Make sure that you choose a list interface from java.util package, and let's pass a type as string, and this is list, and we are going to use ArrayList implementation class to create object of list. Okay, and first we'll see list allows us to add a duplicate elements, right? Let me demonstrate this. I'm going to add a duplicate elements to the list, like let's say element 1, and I'm going to add same element to the list again, and let's say element 2, and I will add same element to the list, and let's print this list to the console, and let's run the program and let's see whether it allows duplicate elements or not. Yes, it allows to add duplicate elements because I have added duplicate element, that is element 1 twice, so it printed duplicate element to the console. It means that list allows you to add duplicate elements. Okay, now let us see. List allows us to add null elements. Okay, so let me add a null elements to the list, null, and let me add one more null value. Okay, and after that I am going to print the list. Okay, let's run the program and let's see whether it accepts null or not. Yes, of course, so we can add a null elements to the list. Okay, great. Now let's see the insertion order. So list maintains an insertion order, right? So let me demonstrate that. So here I'm going to comment out this code, and let's add elements like element 1 and then element 2 and then element 4, and after that element 3 and then element 5. So we have inserted 1 2 4 and then 3 5. So these are the 5 elements we have inserted in a list. When we print this list, we have to get the result as it has inserted in the list. For example, I'm going to print this list to the console, and if I run the program, I would able to see same result should printed to the console. Yes, element 1, element 2 and then element 4 like we have inserted in the list, and then element 3 and then element 5. It means that so list interface maintains a insertion order. Okay, great. Now let's see how to access elements from the list. Okay, so as we know that a list start with the index 0, so let me just print out the elements. So I can use a get method and I can access a 0th index of the list, that is element 1, like this. And let's say I want to access element element 4, then I can pass the index 3. Okay, so this is how we can get an element from the list by using indexes. Okay, so we can use a get method to access elements from the list. Let me run the program and let's see. Yeah, here we go. Element 1, element 3. So list start with the index 0, so this is 0, and this is 1, and this is 2, and this is 3. So if I pass index 3, it should give element 3, not element 4. Okay, and if you want to get element 5 from the list, you need to pass index 4 like this. If you run the program, then you can able to see element 5. Okay, great. So this is how the list interface works. So you can use different implementations like linked list or vector stack. Okay, so we'll learn more about ArrayList, linked list, vector stack in further videos. So this is how the list works, and this is all about list interface. So this is how list allows to add duplicate elements, list allows to add null elements, and list maintains an insertion order, and we can access elements from the list using indexes. Okay, so ArrayList class is a very important candidate of Java collections framework, and ArrayList class implements list interface, and list interface internally extends collection interface. Well, let's quickly take a look into the ArrayList class overview now. ArrayList is resizable array, also called a dynamic array, and it grows its size to accommodate new elements and shrinks the size when the elements are removed. Well, ArrayList internally uses a dynamic array, okay, and it grows its size to accommodate new elements and shrink the size when the elements are removed. It means that ArrayList will increase and decrease its size as per our requirement. So whenever you are not sure about the size of an array, then you should go for ArrayList, because ArrayList will increase and decrease its size as per our requirement. So ArrayList internally uses a resizable array. Let me dive into the ArrayList source code, and let me show you how it internally uses an array. So I am in Eclipse IDE, and this project we have created in previous video, and this is the workspace for throughout this series. This is the GRE system library. Inside that you can find a whole lot of jar files and rt.jar. So this jar file contains all the code packages, and we are going to look into java.util package and ArrayList class present in java.util package. So let's go ahead and let's find out java.util package here. Yeah, here it is. And let's find out ArrayList class. Yeah, here it is. So I have already installed a decompiler in Eclipse so that I can able to decompile .class files. Double click on ArrayList class. So this is the source code of ArrayList class. Okay, and look at here, ArrayList class implements list interface, and ArrayList class is a generic class, and you can pass any type to the ArrayList, and ArrayList internally extends abstract list class, and all the common methods are implemented in abstract list. And look at here, apart from list interface, ArrayList class also implements random access, clonable and serializable interfaces. And look at here, the default capacity of ArrayList is 10. So remember, default capacity of ArrayList is 10. So this is an array that ArrayList internally uses. So you can deep dive into the source code of ArrayList class, and you can understand how the ArrayList internally implemented. Well, if you look at your ArrayList class has couple of constructors. So this is the ArrayList constructor. Here we need to pass an argument, that is initial capacity. If you don't pass initial capacity, then probably you need to call this default constructor or no argument constructor. And if you call this no argument constructor, then by default the capacity is 10. If you go to this variable, this will internally invoke default capacity. Okay, great. So look at here, it will get a default capacity, and default capacity is 10. Okay, if you don't specify capacity to the ArrayList, by default it is 10. Well, by looking into the source code of the ArrayList class, we understood that ArrayList internally implements list interface. Apart from list interface, it will implement random access, clonable and serializable interfaces. And the default capacity of ArrayList is 10, and it internally uses array to store the elements. And there are three constructors in an ArrayList class: no argument constructor, and one more is ArrayList constructor. Here we need to pass initial capacity, and one more ArrayList constructor. Here we need to pass a collection. Okay, so this is the constructor that we need use to create a collection from another collection. Well, this is all about internal implementation of ArrayList, and there are a lot of APIs over there. So in example section we will understand the important methods of ArrayList class. So I just shown you, right, internal implementation of ArrayList class. So ArrayList class internally uses array to store the elements, and array uses index to represent the elements. So ArrayList also uses indexes to retrieve elements, add elements, etc. And ArrayList allows duplicate and null values, so we can store duplicate elements and null values in ArrayList. And ArrayList is an ordered collection, and it maintains the insertion order of elements. It means that in whatever order we insert elements to an ArrayList, in the same order it will display. All right, and you cannot create array list of primitive types like int, char, etc. You need to use a boxer type, that is wrapper classes like integer, character, boolean, etc. So ArrayList is a generic class, right, and generic does not support primitives. So ArrayList, we cannot create with primitive types like int, character. So whenever you want to store numbers like integer numbers or characters, boolean, we have to use a wrapper classes. So alternative to primitive types, we have wrapper classes in Java, right? So whenever you want to store primitive type, then you have to use a wrapper classes with ArrayList. Okay, so this we'll see in example section. ArrayList is non-synchronized. It means that ArrayList is not a thread set. So whenever multiple threads try to modify an ArrayList object at the same time, then there could be a non-deterministic result. Alright, and if you want to use ArrayList in multi-threaded environment, then you should have to explicitly synchronize ArrayList class. So in collections framework, we have collections utility class. So collections utility class provides a couple of synchronized methods to synchronize ArrayList and other collection classes as well. Alright, so I have created Java collections framework project in one of the previous video, and this is ArrayList package, and inside the ArrayList package I am going to create a new class. Right click on a package, new one, then choose class, and let's give class name as ArrayList class example, and choose public static void main method and hit finish. Get rid of this comment, and now we'll see how to create ArrayList object using ArrayList constructor, and we're gonna add new elements to the ArrayList using add method. Alright, let's go ahead and let's create ArrayList class object. Within a main method, let's use list interface as a reference type, and make sure that you import list from java.util package, and let's give a type as string, list of strings, and we're gonna create fruits list new and choose ArrayList class implementation. Alright guys, we just created an ArrayList class object. Okay, now what we'll do, we'll add elements to the ArrayList class object. We can use add method. So add method basically appends a specified element to the end of this list. Alright, so you can just mouse over it and you can read the Java doc. Alright guys, let's go ahead and let's choose add method, and let's add a fruit to the fruit list. I'm going to add banana. Let's go ahead and let's add one more fruit. Let's say apple. Let's go ahead and let's add one more fruit. Let's say mango. Similarly, add one more fruit. Let's say orange. Okay, all right, so look at here, this is the constructor and it is a default constructor, so we are not passing any argument to the ArrayList constructor right here, and the initial capacity of ArrayList is 10. Okay, when we create a empty ArrayList, then the initial capacity of ArrayList class is 10. Okay, you can also define the capacity of the ArrayList. For example, so look at here you can find here are the three constructors. All right, so ArrayList class has three constructors. One is no argument constructor, and another is the parameterized constructor. So here we can pass collection object to the ArrayList class constructor, and here third one is parameterized constructor, and in this case we need to pass the capacity to the ArrayList. Capacity means size to the ArrayList. For example, initial size is 10, If you want to assign the size, you can also give size here. For example, I'm going to say 25. Alright, something like this. Alright, so ArrayList class has 3 constructor, and we have used default constructor to create object of ArrayList class. Now what we'll do is simply print roots object to the console, and if we run the program, we will be able to see all the elements are printed to the console. Alright, so this is how we create ArrayList class object, and here we are using list interface as a reference type. ArrayList class internal implements list interface. If you look at the internal source code of ArrayList class internal implements list interface. Okay, and the list interface internally extends collection interface. Okay, so you can use one of the interface as a reference type, and this is the best practice to use interface as a reference type over here. Alright guys, in this example we understood how to create ArrayList class object and how to add new elements to the ArrayList class object and what are the ArrayList class constructors. Alright, and how to display ArrayList class to the console. In previous example, I have demonstrated how to create ArrayList using ArrayList constructor and how to add a new elements to the ArrayList using add method. Okay, now I will see how to create ArrayList from another collection. For that, I'm going to create a new class. Let's give a class name as create ArrayList from collection example. Okay, and quickly create a main method. Great. We'll see 2 ways we can create ArrayList from another collection. First, we'll see how to create ArrayList from another collection using ArrayList constructor, and second way, how to add all the elements from existing collection to new ArrayList using add all method. Okay, so these are the 2 ways we can create ArrayList from another collection. Let me demonstrate both the ways. Let's go ahead and let's create ArrayList class object first. Create ArrayList class object. Okay, now we are going to store first 5 prime numbers in an ArrayList. For that, let's go ahead and let's use a list interface as a reference type, and here we are going to use an integer wrapper class to store prime numbers. So I already mentioned like ArrayList don't support primitive types, so we have to use wrapper classes, right? So here I have used integer wrapper class in order to store primitive integers. Okay, great. Now let's give a reference variable name as first 5 prime numbers, new, and then ArrayList. Okay, let's go ahead and let's add first 5 prime numbers to the list. Let's use add method. Let me copy this line of code, paste it here. 3, and this is 5, and this is 7, and this is 11. Okay, now we have created a list with first 5 prime numbers. Now we're gonna add this list to the other list. For example, now what I will do, I will create one more ArrayList object here. Let's call it as first 10 prime numbers, and then new, and here I'm going to use ArrayList, and look at here, this is the important. So I'm going to use constructor ArrayList, and here I want to pass a collection as a parameter to the ArrayList constructor, right? So let's go ahead and let's choose this ArrayList constructor, and here we can pass this list to the constructor, ArrayList constructor, like this. Okay, so this is how we can create a ArrayList from another collection. Okay, so look at here, ArrayList constructor has a parameter collection because ArrayList internally implements list interface and list interface extends collection interface. So here we have given a super type as a parameter. Okay, so don't get confused. ArrayList internally implements list interface and list interface internally extends collection interface. So that's why we always prefer to provide super class or super interface as a parameter. Alright guys, now we have added this ArrayList to this ArrayList. Now we'll create one more ArrayList which has next 5 prime numbers, and then we'll add that next 5 prime numbers to this list. Okay, let's go ahead and let's create a list and pass integer as a type, and let's say a reference type as next 5 prime numbers, and then ArrayList. Let's use a default constructor, and let's go ahead and let's add next 5 prime numbers dot add 13. Okay, and let me copy this line of code, paste it here, and let's change the values 17 and 19 and then 23 and one more 29. So these are the next 5 prime numbers. Now I want to add these next 5 prime numbers to the ArrayList object, that is first 10 prime numbers, right? So let's go ahead and let's use this object and call add all method. Okay, add all, and this add all method accepts collection object as a parameter. So let's go ahead and let's pass next 5 prime numbers to the add all method. Okay, now if you look at here, we created first 5 prime numbers, and then we have added this first 5 prime numbers to the first 10 prime numbers object, and then later we have created next 5 prime numbers, and then we have added these next 5 prime numbers to the first 10 prime numbers. Now this object first 10 prime numbers contains 10 prime numbers. Now we can go ahead and we can print the result of this object, and you can able to see 10 prime numbers. Alright, put the sysout system.out.println and just pass this object, and let's go ahead and let's run the program. Yeah, here we go. You can able to see 10 prime numbers. So this ArrayList object contains 10 prime numbers. Alright guys, this is how we can create ArrayList from another collection using ArrayList constructor. This is ArrayList parameterized constructor, and this is how we can create a ArrayList from another collection using add all method. Okay, in Eclipse, let's go ahead and let's create a new class. Let's give a name as access elements from ArrayList example, something like this, and choose public static void main method and hit finish. Great. Now let me quickly write the comments. What are the examples that I am going to demonstrate? So in this example, we will see how to check if an ArrayList is empty using isEmpty method, and we'll see how to find the size of an ArrayList using size method, and we'll also see how to access element at a particular index in ArrayList using get method, and then we'll see how to modify the element at a particular index in ArrayList using set method. Okay, we'll see the usage of these APIs or these methods within examples in this video. Let's go ahead and let's quickly create a list object using ArrayList list, and then choose list from java.util package and type is string, and give reference variable as top programming languages, and then the implementation class is ArrayList Okay, now we'll use isEmpty method to check whether the object is empty or not. Okay, let me quickly write this out here. Yeah, so look at here, I just written a string like is the top programming language is empty. Okay, and here I'm just calling isEmpty method on top programming languages object. Okay, so let me quickly run the program, and if you can see the output here, it should print true. Okay, because empty method isEmpty method returns true if this list contains no elements. Okay, and this object has no elements, hence isEmpty method returns true. Okay, this is the usage of isEmpty method. Let me quickly add few programming languages to the list. Yeah, here we go. I have added C, Java, C++, Python and .NET programming languages to the ArrayList class object. Okay, great. Now we're gonna check the size of the list. Okay, let me quickly use size method to check the size of the list. So look at here, I have provided this out. Here are the top and then object, and just I'm calling size method on top programming languages object, and then this followed by string like programming languages in the world. So this will print here are the top and then size of the object and then programming languages in the world. Okay, great. So let me quickly run the program and let's see how it prints the size. Yeah, here we go. We have added 5 elements to the list, hence the size of the list is 5. Okay, great. So this is the usage of size method. So whenever you want to check the size or length of the list, that is ArrayList object, then you can use size method. Okay, great. Now we'll see how to retrieve the element at a given index. Okay, so let me create a string variable here. Let's say best programming language, and then I'm going to call top programming languages object, and I'm going to use a get method to get element at a particular index. So look at here, get method accepts the index as a method argument. So here I'm going to pass index 1. So this will print Java is a best programming language. Okay, I'm going to just provide a sys out here and just print this object, string object. Alright, so let me run the program and let's see the output. Yeah, here we go. So best programming language is Java. So this is how we can get, or we can retrieve element at a particular location or particular index. Okay, so I'm just pass index 1 to the get method. So this get method will return the element, that is Java, from the object. Okay, great. Now let's say one more example. I want to retrieve an element that is Python. So here I'm going to say second best programming language, and then I can pass index like list index starts with a 0, so this is index 0, and this is 1, this is 2, this is 3, and this is 4. So if you want to retrieve Python, then you can pass index 3 here, and let's go ahead and let's put a sys out and let's see the result. Okay, great. Now let me run the program and let's see. Yeah, here we go. Python is printed on a console. Okay, now let's see how to modify an element at given index. Okay, so look at here, in a list we have 5 elements, right? And I'm going to modify this element. So I'm going to replace this element that is .NET with C hash. Okay, great. Let's call top programming languages object, and this object provides set method. So look at here, set method accepts two parameters. First is integer, that is index, and second is element. Let's go ahead and let's choose this set method, and here we're going to pass index of the element that we are going to modify. So .NET element is present at index 4, so let's go ahead and let's pass 4 here, and then element that we are going to update, that is say hash. Okay, and let's go ahead and let's print the list to the console, provide a sysout, and then pass this object. Okay, let me run this program and we can able to see. So look at here, .NET is updated with say hash. So this is how we modify the list using set method. Alright guys, we have seen the usage of isEmpty, size, get and set methods. Let's go ahead and let's create a class. Right click on a package, new, and then choose class, and let's give class name as remove elements ArrayList, and then choose public static void main method and hit finish. And in this example I'm going to demonstrate the usage of a remove method, and then a remove all method, and then clear method. Okay, so let's go ahead and let's see how we can use these three methods to remove elements from the array list. First of all, we are going to create object of the array list. So make sure that you choose a list from the java.util package, and then pass type as string, array list of type string, and just give the reference variable name as fruits, and then array list. Okay, let me quickly add few elements to the array list. Let's say banana, apple, mango, orange, pineapple and grapes. So these are the few fruits I have added to the array list object by using add method, and this element is present at index 0, and this is at 1, and this element at index 2, this is at 3, this is at 4, and this is at 5. And I have provided sysout to just print this list. So let's go ahead and let's run the program and let's see the output. Yeah, here we go. So we have printed all the list elements to the console. Now let's go ahead and let's use a remove method to remove a particular element from the list. So I am going to remove the element pineapple at index 4. So let's go ahead and let's use a remove method. Let's call fruits object and then call the remove method. So look at here, there are overloaded remove methods. One is first one is remove method, it accepts integer as a parameter, and second remove method accepts object as a method argument. Okay, we're going to first check this one, first remove method, and this remove method accepts index. So we are going to remove the pineapple element at index 4. Let's go ahead and let's pass 4 as an index. Okay, and here I will provide a sysout to just check whether this element is removed from the list or not. Okay, after removing element at index 4, how the list looks like. Let me run the program and let's see how it looks. Yeah, here we go. After orange there is a pineapple, right? So pineapple element is removed from the list. Okay, great. Now let's go ahead and let's use another overloaded remove method. I am going to call fruits and then a remove. So look at here, we have demonstrated first remove method, right? So here is another overloaded remove method. Let's call it is, let's use that one. And here I'm going to remove a mango which is at index 2. Alright, and let me just provide sys out here. After removing mango element at index 2, okay, and just run the program. Yeah, here we go. So look at here, after banana, apple, there was a mango, right, in the list. The mango element was successfully removed from the list. So this is how we can use remove methods to remove element. So this remove method is basically we use to remove element at a given index, and this we can use directly. We can just pass a element to the remove method to remove that particular element from the list. Okay. Now let's go ahead and let's see how to use a remove all method. Okay, so remove all method we can use to remove a collection of fruits. Okay, for example, if you want to remove multiple elements from the list, then you can use remove all. For example, I'm going to remove 2 elements from the collection. For that I need to create a collection over here like this. So look at here, I have created a ArrayList object and I have added apple and banana. Okay, and I want to remove these 2 elements from the main list. For that I have created sub fruits list object. So I can pass this object to the remove all method. So remove all method will remove these 2 elements from the fruits. Okay, just create a ArrayList object and add apple and banana elements to it, and here I am going to call fruits dot remove all method. So look at here, remove all method accepts collection as a method argument, and we can pass sub fruits list as a method argument. After that I will print a list to the console. Let me run the program and let's see the result. Yeah, here we go. Apple and banana is removed from the list. We can able to see only orange and grapes. So this is how we can use a remove all method. So if you want to remove a bulk of elements from the list, then you can use a remove all method. So one more method is there, that is clear. So we can use a clear method to clear all the elements from the list. So let's go ahead and let's clear the ArrayList object. I am going to use clear method to remove all the elements from the list. After clear, if I print the fruits object to the console, it should print empty. Let me run the program and let's see. Yeah, here we go. Okay, so we can use a clear method to remove all the elements from this list. So this list will be empty after this call returns. Okay, great. So we understood the usage of remove all and clear method of ArrayList class. Okay, so whenever you want to remove something from the ArrayList, then you can use these methods. So I am going to first create a class and I am going to name as different. Okay, so different ways to iterate over a list. All right, and here I'm going to create a main method. So let's create a list of courses. So here are the list of courses. Now let's go ahead and let's see different ways to iterate over this array list. Okay, now let's first see how to iterate a list using basic for loop. Okay, so I'm just going to use int I equal to 0 and here I less than courses dot size, alright, and I plus plus. So very simple for loop here. And here what we are going to do is we are going to simply print our list here. So list provides a get method, and here we can pass index as I here, so this will print a list of courses. Alright, so let's go ahead and let's run this program. So here is the output. Okay, so this is a very simple way to iterate over a list using simple basic for loop. Now let's see how to iterate over a list using an enhanced for loop, that is for each loop. Okay, enhanced for each loop. For, and here we just need to pass a string here, and I'm going to give a reference name as course and just give a courses, and here I'm going to just print the course. Okay, so this is the second way. So let's go ahead and let's run this program, and look at here, this is the output. Okay, and now let us see how to iterate over a list using basic loop with iterator. Okay, so I'm just going to write a comment here, basic loop with iterator, and here we're going to use for loop with iterator. So here in Eclipse here are the shortcuts you can choose. Iterate over a collection, so if you select this will give you a iterator. Okay, and here just rename it as a course, and just let's use a sysout to print this course. Okay, now let's go ahead and let's run this program, and look at here the output. Okay, so this is the third way. So very simple, right? Now let's see how to iterate over a list using iterator with while loop. Okay, let me write the comment, iterator with while loop. So let's use a while loop here. So while, and look at here in Eclipse you can find these shortcuts, while loop with iterator. So this will give you the iterator syntax, and you need to here we need to first create the iterator. So let me copy this, and this iterator we need to give in a while loop. Okay, and here we need to provide a type like string, and here is the course. Alright, and here we are going to print a course. It's pretty simple, right? And this is the generic, so we can give a string here like this. Okay, so this is the another way we can iterate over a list using iterator with while loop. Okay, so let me run the program and let's see the output. Yeah, here we go, here is the output. Okay, now these are the very simple ways to iterate over a list using before Java 8. Okay, now let us see how to iterate a list using Java 8 features like stream, for each method, etc. Okay, so let's first see using Java 8 stream with lambda example. Okay, first we will see courses with stream. So we first convert a list into stream here, and we are going to use for each method, and inside of for each method we are going to just print the courses. Pretty simple, right? So look at here, so we are using lambda expression with for each method to iterate over a stream, and first we convert a list into stream, and on top of list we use a for each method to iterate over a stream. So let us say one more way, that is using Java 8 for each method with lambda expression. Okay, so we don't convert list into stream, we directly use for each method on list object. For example, courses dot for each method, and here we are going to print course. Okay, so let's run this program and let's see the output. Yeah, here is the output. So these are the different ways to iterate over a list using Java 7 and Java 8 features. Eclipse IDE, I have created a class. I have named it as a sort list, and here is a main method. Inside main method we are going to write the logic. So first we create a list. Okay, we are going to create a list of integer, and we are going to use ArrayList implementation of list interface. And let's go ahead and let's add a few elements to the list. Here I am going to add 10. I am just going to copy this, and let's add a few more elements to the list. Let's add 30, 20, 50 and 40. So first we will see how to sort a list in a traditional way. Let us see how to sort a list using traditional way, and then we will move to the how to sort a list in ascending order and descending order using Java 8 lambda expression. Okay, so probably you know this class, right? Collections util class. It provides a sort API, and we can use this API to sort a list in ascending and descending order. So here we need to just pass a list to the sort method, and this will by default sort in ascending order. Okay, great. Now let's put a sys out and let's print a list to the console. And here if I run the program, look at here the output. The list is sorted in ascending order: 10, 20, 30, 40 and 50. Okay, now let us see how to sort a list in descending order. So collections utility class provides a API called a reverse, so we can use a reverse API or method to sort a list in descending order. So this will sort a list in descending order. Okay, great. Now let's put a sys out to print a list to the console. Here I'm going to run the program. Here look at here the output: 50, 40, 30, 20, 10. So this is how we sort a list in descending order. So this is very simple. Here just we are sorting a primitive types, that is integer. Now let us say how to sort a custom objects. All right, let's create a employee class, and we are going to sort employees by their salary. All right, so let's go ahead and let's create a class, and let's name it as employee, and let's go ahead and let's create a few fields: private int id, private string name, private int age, and private here just provide a salary, long salary. Okay, let's go ahead and let's create a getter setter methods to access these private fields, and also create a parameterized constructor. It's a pretty simple employee class with these fields. And now let's comment out first, and let's create a list of employee objects, list of employee, and here we are going to use ArrayList implementation of list interface, and let's go and let's add employees to the Here we have an employee list, and we have 4 elements in an employee list. We have 4 employees in an employee list. Alright, now let us see how to sort employees by their salary. Okay, so probably you know the comparator interface, right? So in order to sort custom objects by their fields, for example, in our case we have an employee, and if you want to sort an employee by their salary or name or ID or age, we have to implement a comparator interface, and we need to provide our own logic to sort a custom object. For example, we are going to create here a class which implements comparator interface, and here we need to provide a type that is employee, and comparator interface provides a compare method, and here we need to write the logic. O1 dot, we are going to sort employees by their salary, so let's go ahead and let's call a get salary, and here it's O2 dot get salary, and salary is a type long, so here we are going to provide a cost. Great. Now what we'll do, we'll again call the collections utility class, and here we are going to use again a sort method. So look at here, sort method is overloaded here, so there are two overloaded sort methods, and we are going to use this one list, and with second parameter is comparator. We are going to pass a comparator. Okay, let's pass employees as a post parameter, and second parameter we are going to pass a comparator interface implementation. Now this will sort employees in ascending order. Now let us print employees to the console. For that, first we need to create a toString method inside an employee class. Right click, source, and generate toString, select all and generate. And here we just provide a sysout, and let's print this, and let's run the program, and here you can see the output. So here we have sorted employees in ascending order by salary. First comes 3,50,000, then 4 lakh, and then 4,50,000, and then 5 lakhs. Alright, this is how we sort employees by their salary in ascending order. So in order to sort employees by their salary in descending order, what we are going to use, we are going to swap the reference here, O2 dot get salary minus 1 dot get salary. So this will sort employees by their salary in descending order. So in order to test this, just call the again a sort method, and here just pass a list that is employees, and just use the my sort. So this will now print employees in descending order. So look at here, just comment out this, five lakhs, 4,50,000, 4 lakh, and 3,50,000. So this is how we sort employees in descending order. It's pretty simple, right? So we need to just swap the reference here. Okay, great. So this is how the traditional way we sort a list in ascending and descending order. Let's go ahead and let's use a lambda expression to sort a list in ascending and descending order. So as we know that comparator interface is a functional interface, and we can use a lambda expression to implement a comparator interface. So let's go ahead and let's use a lambda expression to implement a comparator interface, and we'll sort a list in ascending order and descending order. For that, I'm going to just remove this code, and what we'll do, we just again call the collections dot sort method here, and we pass employees. First we'll see the anonymous implementation of comparator interface. So here we pass employees, employee type, and here we need to provide implementation for compare method, and just pass this logic. So this will sort employees in ascending order. Let's put a sys out and let's run the program and let's see the output. So look at here, the employee with 3,50,000 come first, and employee with 4,50,000 and 5 lakh. All right, so what we have done, we have provided anonymous implementation of comparator interface. This will sort in ascending order, right? Ascending order. Now in order to sort a list in descending order, what we have to do is we have to just swap the reference. Let's run the program, and here you can see the employee with 5 lakh salary comes first, and then 4,50,000, 4 lakh and 3,50,000. So this is how we sort a list in ascending order and descending order using anonymous implementation of comparator interface. Now we have anonymous implementation. We can replace this implementation with a lambda expression. So how to do that? It's pretty simple. Collections dot sort, and here what we need to do is we need to pass a first parameter as employees and second parameter as lambda expression. It's pretty simple to convert anonymous class implementation with lambda expression. So what we have to do is just copy this here and let's construct lambda expression. So let's remove this name, method name, because lambda expressions don't have name, and here we also remove the type here. Okay, and we also remove a return, and here we need to provide a lambda expression syntax like this, arrow. Okay, and this is the single statement. We can remove curly braces and open braces and curly braces. So this is the lambda expression. Let's copy this and paste here. Alright, pretty simple, right? So I hope you understood how to construct a lambda expression. Let me explain one more time. So copy this method here outside and remove this name because lambda expressions don't have name, and this is the single statement, so we can also remove a return and this curly braces and open braces, and here we need to provide an arrow like this, and we also remove a type here. That's it. It's pretty simple, right? So this is how we construct a lambda expression from the anonymous implementation, and you can just copy this and here you can just paste here. Alright, pretty simple. Now this will sort a list in descending order because we have swapped our references, right? So let me swap the reference and let us sort a list in ascending order first. Let's run the program and look at here, the employee with salary 3,50,000 comes first, and then like this. Okay, now in order to sort a list in descending order, we need to just swap the reference here. So this will sort a list in descending order. Let's run the program and let's see the output. Yeah, here we go. The employee with salary 5 lakh comes first and then in descending. Pretty simple, right? So this is how we sort a list in ascending order and descending order using lambda expression. Now let us see how to sort an employee by their name. So here we just need to replace a get salary method with get name here, and string provides a compare to method. We are going to use compare to method here and just call o1 dot get name. Alright, pretty simple. Now let's go ahead and let's convert this method with a lambda expression. So lambda expression don't have name, so let's remove this, and this is, let's provide an arrow mark here. This is the lambda expression syntax, and this is a single statement, so we can remove open braces and curly braces like this. Okay, and we also remove return integer, and we also remove the type here, and this is the lambda expression. Let's copy this, and here we need to just replace a second parameter of sort method like this. It's pretty simple, right? I hope you understood how to convert anonymous implementation with the lambda expression. So this will sort employee by their name in ascending order. Let's run the program. So look at here, Ramesh comes first, and then Santosh, and then Sanjay, and then Pramod. Sorry, here we need to provide O2, right? Yeah, so again run the program and let's see the output. Pramod comes first, and then Ramesh, and then Santosh, and then Sanjay, and then Santosh. Okay, let's sort employee by descending order. So we need to swap the reference like this, O2 and O1. So this will sort employee by their name in descending order. Let's run the program. So look at here, Santosh comes first, and then Sanjay, and then Ramesh, and then Pramod. So this is how we sort employee by their name in ascending order and descending order using lambda expression. In collections hierarchy, linked list class implements list interface as well as DQ interface. Linked list internally uses doubly linked data structure to store data elements. So doubly linked list is a data structure. It holds a collection of nodes. For example, let's say this is the node, okay, and each node in a doubly linked list is divided into 3 parts, and this is this part contains the pointer to the previous node, and this part contains a pointer to the next node, and this middle part contains data. Okay, so double linked list is basically a collection of nodes, and each node consists of these 3 parts. Linked list internally uses doubly linked list to store the data elements. Okay, great. Like ArrayList, linked list also contains duplicate elements, and linked list class maintains insertion order. It means linked list class also preserve insertion order, and linked list class implements queue and DQ interfaces. Therefore, it can also be used as queue, DQ, or stack. And linked list class is not a thread set. It means that whenever you want to use linked list in multi-threaded environment, then you should have to explicitly synchronize linked list class. Okay, and we have collections utility class in collections framework. So collections utility class provides static methods to synchronize collection classes. For example, collections utility class provides synchronized list method, so which we can use to synchronize a linked list class. Okay, so this we will see in example section. All right, great. So now we know that linked list and ArrayList both classes implements list interface. Okay, and there are a few key differences between them. So let's quickly understand the difference between ArrayList and linked list. Okay, so ArrayList internally uses arrays to store the data. It means that ArrayList is an index-based data structure backed by array. Okay, on the other hand, linked list internally uses doubly linked list to store the data elements. So this is the first difference. The second difference is that insertion, addition, or removal operations are faster in linked list, because in linked list there is no shifting of shifting required, because in case of ArrayList, if we remove any element in the middle, or if we add any new element in the middle of the ArrayList, then there are a lot of shifting required, because ArrayList is backed by array. It means ArrayList internally uses indexes to represent elements. For example, so look at here, this is the ArrayList, starts with index 0. Let's say we have 10 elements within ArrayList. If we remove any element at the middle of the ArrayList, then there are a lot of shifting required. Okay, sometime if we add a new element to the array list, then array list internally creates a one more array to store all the data from the original array into the new array. So this is how the array list resize its structure internally. Okay, got it. So whenever you have insertion and removal operation at the middle of the list, then linked list is the best choice and it's faster. Okay, great. And the third difference is linked list consumes more memory than array list, because linked list internally uses doubly linked list, right? And doubly linked list is basically contains a collection of node, and each node consists of three parts. So look at here, this is the node and it consists of three parts. So this part, middle part, contain data, and this part contain next pointer to the next node, and this contains pointer to the previous node, and some amount of memory is required to store these references also. Okay, and hence linked list consumes more memory than array list. So look at here, array list basically requires memory to store element and its index, and in case of linked list it takes a little bit more memory to store pointers, that is next and previous pointers apart from data. All right, so this proves that linked list consumes a little bit more memory than array list. All right, so these are the few key differences. Let me recap the differences. In case of structure, array list internally uses array to store the data elements. It means array list is index based data structure backed by an array, and linked list internally uses doubly linked list to store the data elements. Okay, this is how the structure implemented inside array list and linked list. And in case of performance, whenever you have operations like insertion and deletion at the middle of the collection, then linked list is much more faster than array list. Okay, and in case of memory usage, linked list consumes more memory than array list, because linked list internally uses doubly linked list, and doubly linked list is a collection of nodes, and each node consists of three parts, so each part takes some amount of memory. That's why linked list consumes more memory than array list. All right guys, this is a quick overview of linked list class and the key differences between array list and linked list. So I'm in Eclipse IDE. We have Java collections framework project in Eclipse IDE. Let's go ahead and let's create a new package. So we're going to create a lots of examples on linked list. So let's go ahead and let's create a separate package for it. Let's say the package name is linked list. Hit finish. Now let's go ahead and let's quickly create a class. Let's give name to the class like create linked list example, something like this, and choose public static void main method and hit finish. Great. Now I'm going to demonstrate few methods of linked list class, like add method to add a new element to the linked list, and we have one more overloaded add method to add a new element to specific position. So it takes this location. For example, let's say we want to add element at location 2 and then element name. Okay, and one more method is add post and add lost. So look at here, the important point is add post and add lost. So these are the methods which comes from DQ interface. So as I mentioned in previous video, linked list implements list interface as well as DQ interface, and add post and add lost methods comes from DQ interface. Okay, great. Let me quickly create a linked list instance. Let's say linked list and just pass string as a type, and let's give reference variable name as fruits and new and then linked list. Now let's go ahead and let's quickly add some fruits to the list. Fruits and then use add method. So look at here, there are overloaded add methods. I'm going to use first one, and let's quickly add a element, that is banana, and let's quickly add a few more elements to the linked list. Let's say apple and mango. Okay, now what I will do, I will simply print this list to the console. Let's run the program and let's see the output. Yeah, here we go. We have 3 elements in the linked list. Now let's see how to add an element at a specific position in linked list. Fruits and then call add method. So look at here, we are going to use second add method, and we're going to pass index. So we are going to add a new element at index 2. Let's give element name like watermelon. Let's go ahead and let's print this list to the console. System.out.println, and let's say after adding watermelon, how the list looks like. Fruits, and let's go ahead and let's run the program. Yeah, here we go. So look at here, the watermelon element is added to the linked list at position 2. Now let's see how to add element at the beginning of the linked list. Okay, adding element at the beginning of the linked list. Let's call our fruits list and then call add post method. Okay, so look at here, add post method, it inserts the specified element at the beginning of the list. Okay, let's go ahead and let's call this method, and look at here, add post method is in DQ interface, not in a list interface. Okay, great. Just give an element name as strawberry, and let's go ahead and let's print the list. Let's say after adding strawberry, how our list looks like. Let's go ahead and let's run the program. Yeah, here we go. Strawberry is added at the beginning of the linked list. Okay, great. So this is how we add element at the beginning of the linked list using add first method. Now let's see how to add element at the end of the linked list. Adding element at the end of the linked list. Let's call fruits and then call add last method. So look at here, add last method is present in DQ interface. Alright guys, let's go ahead and let's add an element at the end of the linked list. Let's say orange, and let's go ahead and let's print the list. System.out.println, after adding orange, let's run the program and let's see how the output looks like. Yeah, here we go, orange is added at the end of the list. Alright, great. Alright guys, this is an example to demonstrate the usage of add first, add last methods. Okay, I hope you understood how to create a linked list and how to add elements to the linked list. Now let's go ahead and let's create a class, and let's give a class name as retrieve linked list elements example, and choose public static void main method and hit finish. Now let's see the different ways to retrieve elements from the linked list. We're gonna see how to get a first element in a linked list, how to get a last element in a linked list, and how to get an element at a given index in a linked list, and how to get all the elements from the linked list. Okay, so these are the examples that we are going to look into in this video. Let's first create a linked list object. Let's call the reference variable as fruits and then again linked list. Let me quickly add few elements to the fruits list. We have created a linked list instance and we have added few elements to the linked list. Now let's go ahead and let's see how to get first element in a linked list. So linked list provides get first method to get a first element in a linked list. So let me quickly write the comment here, getting first element in a linked list using get first method. Let's create a string variable, let's say first element, and then fruits object and then call get first method. So look at here, get first method is present in DQ interface. Okay, and this method returns first element in the list. Okay, so if you want to know more about methods, you can just mouse over it and you can read the Java doc like this. Okay, great. And I'm going to just print the element to the console, first element, something like that, and let's say first element. If you run the program, you would be able to see banana is printed to the console here. This banana is the first element in the linked list, right? Alright guys, let's see how to get a last element in a linked list using get last method. Let me quickly write the comment, getting last element in a linked list using get last method. Let's create a string variable and let's say last element and fruits object and then call get last method. So if you mouse over on the get last method, so look at here, get last method is also present in DQ interface and this method returns a last element in the list. Okay guys, great. Now let me go ahead and let me print this element to the console. So this is gonna last element. Let me change the string last element. Let me run the program and we would be able to see the pineapple is printed on a console. So look at here, fruits list and pineapple is at a last position, so pineapple is printed in a console. Okay, great. Now let's quickly see how to get an element at a specific position in the linked list. Let me write the comment, getting an element at a given position in the linked list. So linked list class implements list interface and list interface provides a get method, right? So we can use a get method to get an element at a given position. For example, create a string variable like string and then element equals to and then object fruits object and then call get method. So look at here, get method is present in list interface and it returns an element at a specified position in the list. Okay guys, call the get method and pass the index. So I am going to retrieve apple, so let's pass 1 and let's print element to the console. Let me run the program. Yeah, here we go, apple is printed in a console. Now let's see how to retrieve all the elements from the linked list. So there are many ways to loop over a linked list and or iterate over a linked list. Okay, so we can use either iterator, for each loop, a lambda expression, or there are many options to retrieve elements from the linked list. Alright guys, so I'm going to use a simple for each method to iterate over a list, and I'm going to just print the element. Okay, element, and let me rename this. Alright, so element is duplicate elements, right? So let me rename this. Let's say element 1, or let's call it as fruits. Fruit, this is singular, let's call it as a fruit. And let me run the program, and you can able to see all the fruits are printed in a console. Alright, so this is the example to demonstrate how to get a first element in a linked list, how to get a last element in a linked list, and how to get element at a given index in the linked list, and how to get all the elements from the linked list. So you can use a for each loop or iterator to retrieve elements from the linked list. Let's go ahead and let's create a new class, and let's give class name as remove elements from linked list example, something like that, and choose public static void main and hit finish. Yeah, here we go. Now let me quickly write the comments what examples I am going to demonstrate. So we'll see how to remove first element in a linked list, how to remove last element in a linked list, and how to remove the first occurrence of a given element in a linked list, and how to clear the linked list completely. For that, let's go ahead and let's call linked list and pass string as type, and this is boot list, and then call new linked list. Okay, great. Now let me quickly add few fruits to the fruits list. So look at here, I have added apple, banana, mango, pineapple fruits to the fruit list, and I have printed fruit list to the console. Let me run the program, and you will be able to see all the elements are printed to the console. Now let's see how to remove first element in the linked list. Let me quickly write the comment here. Remove first element in a linked list. So let's go ahead and let's create a string variable, and let's call it as element, and then this is fruit list, and then call remove first. So look at here, remove first method is present in DQ interface, and this method removes and returns the first element from the current list. Okay, now I am going to print the list. So after removing first element, let's see how our list looks like. Okay, let's go and let's run the program, and here you can able to see after removing first element you can able to see only banana, mango, pineapple. Okay, great. Now let's see how to remove the last element in a linked list. Let me write the comment remove last element in a linked list, and let's go ahead and let's call the method remove last method. Okay, so this method removes and returns the last element from this list, and this method again present in a DQ interface. Okay guys, and let me print the list after removing the last element. After removing last element, we can able to see banana and mango in the console. Okay, apple and pineapple, these two elements are removed from the fruit list using remove first and remove last methods. Okay guys, now we're going to use a remove method to remove first occurrence of a given element in a linked list. Let's go ahead and let's call root list object. Let's call remove method, remove, and just pass the index. So here you can see we have two overloaded methods. So first method is present in a list and second method is also present in a list. So first method you can use to pass the index, second method you can use to directly pass element name. So I'm going to use second one and I'm going to pass the name of the element like banana. So I'm going to remove banana element from the list, and then let's go ahead and let's print the list to the console. And if you run the program and you would be able to see mango is printed in a console. So we have removed apple, banana, pineapple, only mango is left in the list. That's why mango is printed in a console. Now let's see how to clear the linked list completely. So we can use clear method, right? We can use a clear method to clear the list, and clear method is present in a list, okay, list interface. So we can go ahead and we can call the clear method. So after cleaning a linked list, we can just check if there are any elements. This should be empty. If you run the program and you'll be able to see the square brackets here, it means that linked list is cleared. Okay, we can use clear method to clear linked list completely. Alright guys, so these are the few methods like remove first, remove last, and remove and clear. So these are the few methods that you can use to remove elements from the linked list. Alright, I'm going to demonstrate how to search an element in a linked list and how to iterate over a linked list with an example. Let me quickly create a linked list. Let's say we have a linked list with list of programming languages like C, C++, Core Java, Java EE, Spring Framework, Hibernate Framework. Now I want to check whether a particular element is present in a list or not. For that I am going to use contains method. For example, let's call a contains method. So contains method returns true if the list contains the specified element. Okay, so let me go ahead and let me check the C element. Okay, and this method returns true. It means we have to use boolean as a type here. Let me print the result to the console. The result. Alright, so let's run the program and you'll be able to see true is printed because C element is present in a list, linked list. Okay, so this is the usage of contains method. Now let's see how to find index of first occurrence of element in the linked list using index of method. For example, I want to get an index of core Java element. For that, what we can do is we can simply say int and let's say index equals to call programming languages object and then call index of method. So look at here, index of method returns the post occurrences of a specified element in the list. Okay, and let's pass the element, let's say core Java, and let's print index to the console. And if you run the program, we'll be able to see 2 is printed on the console because core Java element is present at index 2, right? So this is at index 0 and this element is at index 1 and core Java element is at index 2. That's why it is printed 2. Okay, so this is the usage of index of method. Now let's see how to find the index of last occurrences of an element in the linked list using last index of method. Okay, for example, let's say int, let's call it as last index and call last index of method. So last index of method returns the index of the last occurrences of a specific element in the list. Alright, so let's go ahead and let's pass Spring Framework as an element to the method. And let's go ahead and let's put the sys out here and let's say last index of the occurrence of the element. So what I will do, I will create one more, I will add one more element like Spring Framework. So look at here, I have added Spring Framework element twice, and if I run the program, I would be able to see the index of last occurrences of an element in the linked list. You see different 5. Okay, so last index of means it will find the index of last occurrence of an element in a linked list. Okay, great, it's pretty simple. Alright guys, we understood how to search an element in a linked list. Now let's see how to iterate over a linked list. So there are many ways to iterate over a linked list. We can use a iterator, or you can use for each method, or you can use for each advanced loop, and we can also use simple for loop. Alright, let's first see how to use a iterator object, programming languages object, and then call iterator. So look at here, iterator method returns iterator over the elements in this list in a proper sequence. Let's go ahead and let's call iterator method, and this iterator method returns a iterator object. Let me just simply copy the return type and paste it here and give a reference like iterator. And here we can use while loop, while with iterator, and we can just print the element to the console. Okay, you can just rename this method variable, let's say prog, and if you run the program, and you'll be able to see all the elements are printed in a console. Now the second way is we can use for each method. So for each method is introduced in Java 8, and we use lambda expression to provide implementation for functional interfaces. For example, here we have programming languages object, and if I call for each method internally uses consumer interface, and we have to use lambda expression to implement consumer interface. And here we're going to use lambda expression here, so arrow syntax, and put this out here and just pass element. That's it. And if you run the program, you will be able to see the list is printed in a console. It's pretty simple, right? Great. Now let's go ahead and let's use for each loop. It's pretty simple. String, let's say element e, and then programming languages, and put the sys out here and just print e. And if you run the program, and you'll be able to see the list is printed to the console. Alright guys, so these are different ways to iterate over a linked list. So in this example, I have demonstrated how to create a linked list, how to add elements to the linked list, and how to search elements in a linked list using contains, index of, last index of, and different ways to iterate over a linked list like using iterator, for each method, for each advanced loop, and you can use a simple for loop to iterate over a linked list. So we are going to discuss difference between array list and linked list in Java. So this is one of the frequently asked interview question, especially for beginners in Java interviews. Let's go ahead and let's discuss the difference between array list and linked list in Java. Well, before deep dive into the differences between array list and linked list, let's quickly have a look into the overview of array list class and linked list class in our Java collections framework hierarchy. So look at here, we have Java collections hierarchy, and at the top collection interface is a root interface, and we have a list, queue, set, dequeue, and sorted set core interfaces in Java collections hierarchy. And on the other hand, we have also map interface and HashMap, link HashMap. So these are the implementation of map interface. And look at here, array list class implements list interface. Alright, and linked list class implements list interface as well as dequeue interface. Okay, got the key here. Array list class implements list interface, but linked list class implements both list and dequeue interface. Hence, array list is only used for list and linked list is used for list as well as queue. Okay, great. Now let's take a look at the differences between array list and linked list. Array list internally uses dynamic array to store the elements. On the other hand, linked list internally uses doubly linked list to store the elements. Well, let me explain you with a diagram. So array list internally uses an array, right? For example, consider we have array starts with index 0, and let's say we have 10 elements in array list. So array list internally uses array, and array list start with index 0. Okay, and linked list internally uses doubly linked list to store the data. So basically doubly linked list is a data structure, and it is a collection of nodes, and each node consists of 3 parts. For example, let's say this is the node which is present in doubly linked list, and each node has 3 parts. So first part is the previous pointer to the node, okay, and this part is a next pointer to the next node in the collection, and this middle part contains a data. Okay, so these are the 3 parts in a node. Okay, got it. So linked list internally uses doubly linked list to store the data elements. So this is the difference. So next difference is manipulation with array list is slow because it internally uses an array. If any element is removed from the array, all the bits are shifted in a memory, whereas manipulation with a linked list is faster than array list because it uses doubly linked list, so no bit shifting is required in memory. Let me explain this point with a diagram. So look at here, array list internally uses array, right? So whenever if we remove an element in an array list at a middle, then there are a lot of shifting required. Okay, let's say if we have 1 2 3 and up to 10 elements in an array, if we remove third element from the array list, then this should be shifted, right? This element should be shifted in this location, and again this element should be shifted here. So there are a lot of shifting required in a array. Okay, and array list internally uses arrays, so array list is a little bit slow for manipulation. Okay, and linked list internally uses doubly linked list, so there is no shifting required in a linked list. Alright, understood? Next difference is ArrayList consumes a less memory than linked list, whereas linked list consumes a more memory than ArrayList because it stores the next and previous references along with the data. For example, let me quickly draw a diagram here. Let's say this is an array, start with index 0, and let's say we have 10 elements in array. So this is the array, array list. Array list internally uses array, right? And we have a linked list. So linked list internally uses doubly linked list, right? And doubly linked list contains a collection of nodes, and each node consists of 3 parts. And this part contains reference to the next node, and this part contains a pointer reference to the previous node, and this part contains the data. Well, in terms of memory usage, so linked list consumes a more memory than array list because linked list also stores a previous and next references along with the data in a collection. But in case of array list requires only memory to store an element along with its index. But in case of linked list requires a little bit more memory to store previous and next references. Okay, got the point? And next difference is ArrayList class can act as a list only because it implements list interface, only list interface. On the other hand, linked list class can act as a list and queue both because it implements list and dequeue interfaces. Well, so look at here collections framework hierarchy. As we have mentioned earlier, like ArrayList class only implements list interface. On the other hand, linked list class implements list and dequeue interfaces. So linked list can be used as a list as well as queue, but ArrayList only used as a list. Alright, I hope you understood this point. So ArrayList is better for storing and accessing data. Linked list is better for manipulating data. For example, so in case of ArrayList, if you want to insert or remove elements at a middle, then ArrayList performance wise it's a bit slower because there are a lot of shifting required. But in case of linked list, if you have insertion and removal operation at the middle of the collection, then linked list performs very good. Okay, so one more point I want to discuss, like when to use ArrayList and when to use linked list. So whenever you want to perform insertion and removal operation at the middle of the collection, then highly suggested to use a linked list. Alright, so in other cases like in a retrieval operation, ArrayList is much better than linked list. Alright, I hope you got this difference. Alright guys, these are the few differences between ArrayList and linked list, and there are similarity between ArrayList and linked list, like ArrayList also contains duplicate elements and linked list also contains duplicate elements, and ArrayList and linked list both maintains the insertion order, and ArrayList and linked list both can contain null values. So these are the few similarities between ArrayList and linked list. Alright guys, I hope you understood the difference between ArrayList and linked list. So these are the few important points and differences so that you guys can remember and you guys can explain in interviews. Guys, HashSet class is very important class in Java collections framework because we use HashSet class to store unique elements or unique values. Okay, so here the few important points about HashSet class. Let's quickly take a look into these important points about HashSet class with an example. HashSet cannot contain duplicate values. So as we know that set does not allow duplicate elements or values, so HashSet class implements set interface, hence HashSet class cannot contain duplicate values. So let me demonstrate this point with an example. Let's switch to the Eclipse IDE. Over there I have written a code to demonstrate these points. So look at here, in Eclipse IDE I have created project, and this is a class. Inside this class I have written this method to demonstrate HashSet not contain duplicate elements. So this is the method. Inside this method I have created a HashSet object, and I try to add a duplicate element. So first I have added element 1, and then I try to add a same element. Alright, so this is the duplicate element, right? Because look at here, both the elements are same. So if you try to run this program, so this program basically prints element 1. So a HashSet basically internally override this existing element with this element. Okay, so HashSet, whenever it finds a duplicate element, it will basically override the existing and it will place a new one. Alright, so let me run this program and let me show you the output. So look at here, this program prints element 1. So even though I try to add two elements, but it prints only one, because HashSet, if it finds duplicate elements, then it will override the existing one. Alright guys, so this program demonstrates that HashSet cannot contain duplicate elements. So next point is HashSet allows null value. So HashSet basically allows only one null value. Let me demonstrate this point with an example. So look at here, I have created a method null value demo. So inside this method I have created a set object, set class object, and I have added two null values. Alright, so as I said, like set can contain only one null value. If we try to add multiple null values, it will replace the existing null value. Alright, so let me run the program and let me show you. Yeah, look at here, HashSet basically allows one null value to store inside it. Alright guys, just remember, HashSet can contain one null value. Let's take a look at next point. HashSet is an unordered collection. It means that it does not maintain the order in which elements are inserted. Let me demonstrate this point with an example. So look at here, I have created a method unordered demo. So then this method demonstrates that HashSet does not maintain the order. So I have created a HashSet object and I have added few elements to it, and look at the order here, element 1 2 4 5 7 6. If I run this program, so look at here, 1 2 4 5 6 7. Alright, so look at here, 7, element 7, it comes before element 6, but in output it comes at the end. Okay, so every time you run the program, it prints the elements unorderly. Alright guys, it means that HashSet does not maintain order. Okay, it is basically an unordered collection. I hope you understood these points. Let's take a look at the next point. HashSet internally uses HashMap to store its elements. Alright guys, let me quickly deep dive into the HashSet internal source code and let me show you whether it is using HashMap to store its element or not. Alright. Alright guys, I have already installed a decompiler, so I can able to decompile this HashSet class. So let me quickly go inside a HashSet class source code. Yeah, here we go. So look at here, HashSet class internally uses HashMap to store its elements. Alright, understood? So this is the HashSet class source code, and HashSet class internally uses HashMap to store its elements. I hope it clears this point. Now let's take a look into the next important point. HashSet is not a thread shape. Alright guys, HashSet is not a thread shape, so you don't need to use HashSet in multi-threaded environment. So I highly recommend you guys do not use HashSet in multi-threaded environment. So if you want to use HashSet in multi-threaded environment, then you should have to explicitly synchronize it. So there is a collections utility class in collections framework. It provides a lot of static methods which you can use to synchronize explicitly to a HashSet class. Alright guys, and alternative to HashSet class, there are some more concurrent classes out there in a collections framework that you can use in multi-threaded environment. Alright guys, these are the few important points about HashSet class. And let's switch to the Eclipse IDE. So look at here, this is a project I have created in one of the video, and this is a package, HashSet package. Right click on HashSet package, new, and then choose class, and let's give class name as create HashSet example and choose main method and hit finish, and just remove this comment. And basically what we are going to do in this video is like we are going to create an example to demonstrate how to create HashSet using HashSet constructor, and we add a new element to HashSet using add method. So let's go ahead and let's first create a HashSet object. So we are going to use set interface as a reference type, so make sure that we import set interface from java.util package, and let's give reference a variable name as programming languages, something like this, and then new, and then HashSet. So this is the HashSet is a class which implements set interface, and we are going to use set interface as a reference type. So look at here, HashSet has multiple constructors, and here we are going to use the default HashSet constructor. Alright guys, once we create a HashSet object, let's go ahead and let's add elements to it. We are going to use add method. So look at here, add method basically we use to add a new elements to HashSet object. Alright, let's say C. So C is a programming language, right? Now let's go ahead and let's add one more programming language to the set. Let's say C++, and let's quickly add one more element. Let's say Java, and let's use add method to add few more elements. Let's say Python, and let's go ahead and let's add one more element. Let's use add method, and then just say element name like Scala, and let's add one more programming language like JavaScript. Alright guys, we have created a HashSet object and we have added a few programming languages to it. Let me just print it to the console, and let's save the program, and let's go ahead and let's run the program now. Right click, run as Java application, and here we go. This is the output. So look at here guys, the output is unordered. Alright, so HashSet is basically an unordered collection, right? And whenever you print HashSet, the order of the elements is scattered. Alright, it does not maintain in such an order. Now let's add a duplicate element to set, and let's see what happens. So I'm going to add one more element with the same name like Java, and let me just print this set after adding duplicate element. Let's go ahead and let's program, and let's see. Yeah, here we go. So if you try to add a duplicate element, a HashSet will basically replace the existing element. Okay, it does not allow to add duplicate elements. Alright guys, so look at here the constructor. So basically here we have 4 constructor. HashSet has 4 overloaded constructors here. You can use default HashSet constructor, and here are the parameterized HashSet constructors. Alright guys, and look at here, HashSet internally uses HashMap to store the values. Alright, so this is very important guys. Just remember, HashSet internally uses HashMap to store the elements or the values. To get a more hands-on experience on HashSet class, let's go ahead and let's create one more example. So let's create example to demonstrate how to create HashSet from another collection. Alright guys, let's switch to the Eclipse IDE, and look at here, this is the project and this is the HashSet package. Let's go ahead and let's create a class, and let's name as create HashSet from collection example, and choose main method and hit finish. Now basically what we are going to do in this example is we create a HashSet from another collection using HashSet constructor, and then we use add all method to add existing collection to HashSet. So these are the two different ways we can create a HashSet from another collection. Alright guys, so what we will do, we will create a HashSet object and then we use HashSet constructor to add a HashSet collection to another HashSet collection, and then later we will also see how to how to create HashSet from ArrayList collection. So let's go ahead and let's create a object of HashSet. Let's say first even numbers, first 5 even numbers, new, and then HashSet. So first we'll add 5 even numbers to set object. Let's say 2, 2, 4, 6, 8, 10, right? Alright guys, we have added 5 even numbers to the set object. Now what we do, we'll create one more set object and we add this first 5 even number set to it by using HashSet constructor. So let me show you how to do it. So just call this HashSet object as 10 even numbers, new, and HashSet. So look at here, this is important. So we are going to use parameter constructor, and here we need to pass a collection. Alright, so collection is, in our case, it's a set. So set is interface which internally extend collection interface, right? So we can create a HashSet from another HashSet like this. Now let me just print and let me run the program. So here you can see we have successfully added one collection to another collection. Now let's go ahead and let's create one more HashSet object, and let's say next 5 even numbers, new, and then HashSet. Now let's go ahead and let's quickly add next 5 even numbers to this object. Let me quickly copy and paste it here, and let me change the values accordingly. 12, 14, 16, 18, and then 20. Alright, now let's go ahead and let's use add-all method to add a collection to HashSet object. So let me just give appropriate comments to, let me just copy this. Alright, now let's go ahead and let's use add-all method, 10 even numbers dot add-all. So we are going to use add-all method to add a collection to HashSet object like this. Alright guys, let me go ahead and let's print the HashSet object, and let me run the program here, and here we go. So look at here, this is the first 5 even numbers and this is the 10 even numbers. Let me just comment out this and let me run the program again, and here we go. Alright, this is how we create a HashSet from another collection by using HashSet constructor and add-all method. So now what I will do, I will just replace a HashSet object with ArrayList object. So let's go ahead and let's create ArrayList object. So list interface extends a collection interface, right? So we can also create a HashSet object from ArrayList collection. Alright, we have created ArrayList object and added 5 even numbers to it, and look at here, we are just passing post 5 even numbers to a HashSet using constructor. So let me also replace here set with list object. Just copy this and new, and then ArrayList. Pretty simple guys, we are just creating a HashSet from ArrayList object. So look at here we are using first 5 human numbers and next 5 human numbers, and then just we are adding by using add-all method. And look at here, HashSet constructor has collection as a argument, right? And we are passing ArrayList object to it. Let me just run the program and let's see the output here. Here we go. It's pretty simple, guys. So we have created HashSet from another collection like ArrayList in this example. Let's create an example how to remove elements from HashSet. Alright guys, let's switch to the Eclipse IDE and look at here is project and this is the package. Let's go ahead and let's create a class and let's give a name and choose main method and hit finish. Alright guys, now in this example I'm going to demonstrate how you can remove a particular element and how to remove a collection of elements from HashSet and how you can clear HashSet using clear method. So look at here, these are the three methods that we are going to see in this video. So this is a clear method which clear the HashSet completely by removing all the elements, and let's go ahead and let's see the usage of all these three methods with an example. So let's go ahead and let's first create HashSet object. Let's use set interface as a reference type here and just give type as integer and reference variable name numbers, new HashSet. Let's use default HashSet class constructor. Alright guys, and here just add first 10 numbers to the numbers object like 1 2 3 4 up to 10. Let me just quickly copy paste it and let me quickly change the values 1 2 3 4 and 5 6 7 8 9 and 10. Alright guys, now let's go ahead and let's see how to remove a particular element or value from HashSet using a remove method. Okay, great. Now just type numbers and dot and then remove. So just you can read the description of a remove method here. So you can use remove method to remove an element from HashSet and it returns true if the element is there in HashSet, otherwise return false if element is not there. Let me just remove element 1 from the HashSet object, and let me also capture the return type of remove method here. It's a boolean, just print the boolean value to console using sysout result. Alright, let's say remove result. Okay, remove method result, and after removing this element we also need to print the HashSet, right? Let's provide a sysout and just pass the numbers. It's cool. Now let's go ahead and let's run the program, and here we go. So one is successfully removed from object, and you can able to see here the numbers printed from 2 to 10. Alright, this is the usage of remove API or remove method. Let's see how to use remove all method to remove a collection or a set from existing set. So let me just quickly create a set object called even numbers, and I'm going to basically remove even numbers from numbers object. So for that, let's go ahead and let's create even numbers object, and let me just add all the even numbers, I mean the even numbers that are there in. Let me quickly add even numbers 2 4 6 and 8. So these are the even numbers that I want to remove from the set object, that is numbers object. Okay, now what we do is we just call a remove all method here. So you can read the description of remove all method. So remove all method takes collections as method argument, and in our case even numbers is a collection, right? And just print these numbers to console. So let's go ahead and let's just comment out the existing sysout and run the program, and you can able to see here the result. Oops, so 3 is not even number. Let me just replace with 4. 2 4 6 8 10. Let's run the program, and here we go, 35079. So these are the odd numbers that remained in the set object. Now let's go ahead and let's use clear method to clear completely, to remove all the elements from HashSet. Let's go ahead and let's use clear method here and just put the sys out. So after using clear method, the HashSet should be empty. Let me show you. Let's run the program. Yeah, so here we go, HashSet is empty after clearing all the elements from the HashSet. Alright guys, so these are the 3 APIs that we have demonstrated in this video: remove all, and clear. 5 different ways to iterate over a HashSet in Java. Alright, so the first way is using enhanced for loop, second way basic loop with iterator, third way while loop with iterator, fourth way Java 8 for each method with lambda expression, and fifth way is Java 8 streaming with for each with lambda expression. Alright, so these are the 5 ways we can use to iterate over a HashSet. Alright, so let's go ahead and let's see each of them with an example. So let us see how to iterate over a HashSet using enhanced for loop first. So before that, let's create a set of courses. So let's use a type as string here. I'm going to give a reference as courses, and here we are going to use HashSet. Okay, and let me quickly create few courses. So here Java, C, C++, Python, and Scala. Alright, so these are the 5 courses we have added to the courses set. So now let's use a enhanced for loop to iterate over a set. It's pretty simple. Use a for loop, and here we are going to use string and course. Here we are going to use courses. Okay, and here just put the sys out and just print the course to the console. It's pretty simple, right? So using enhanced for loop is pretty simple. Okay, so let's go ahead and let's run this program and look at here the output. Okay, so this is how we can use an enhanced for loop to iterate over a HashSet. Alright, so let us see the second way. The second way is using basic loop with iterator. It is pretty simple. So use for, and here in Eclipse you can find the shortcuts here. So just choose iterate over a collection, and this will give you a syntax, and here just refactor it, and here we are going to print course to the console like this. It's pretty simple, right? And here it's a generic, so let's go ahead and let's provide a type as a string here. It's pretty simple, right? So let's go ahead and let's run the program, and here we go. So here is the output. Okay, so it's pretty simple using for loop with iterator. Now let's see how to use a while loop with iterator to iterate over a HashSet. So let's use a while, and here choose iterator with iterator. Okay, and this will give you a syntax, and here we need to first create a iterator like this and provide a iterator to the while loop like this, and here we need to give a type as a string, and here just refactor this reference name as a course, and here we are going to print to the console like this. Pretty simple, right? So using while loop with iterator is pretty simple. So let's go ahead and let's run the program. Yeah, here we go. Here is the output. Okay, now the next way is using JDK8 for each method with lambda expression. This is very simple, and if you are using Java 8, then I highly recommend you guys to use this syntax. So first let's get the courses dot for each, and here what we'll do, we'll just provide a course, and this is the syntax for lambda expression, and give us this out here and just print to the console. So look at here how the code looks like. Alright, and one more thing is set interface. It extends internally collection, and collection interface extends iterable interface, and iterable interface provides a for each method. So look at here for each. Alright, So set method internally indirectly extends iterable interface, so set can able to use this for each method. So that is what we are using here. Okay, it's pretty simple, right? So let's go ahead and let's run this program and let us see the output. So here is the output. All right, so let me comment out so that you will understand. So I just commented out the existing code, and here I am going to just run the program again and we'll see the output. Yeah, here we go. Okay, so this is how we iterate over a HashSet using Java 8 for each method with lambda expression. So let us see the next way to iterate over a HashSet. So next way is using Java Stream API with for each method and lambda expression. Alright, it's pretty simple. Let's go ahead and let's convert set into stream first. And stream provides a filter method, so we can use it and we can apply some filtering conditions on top of stream here. So I'm going to apply some condition, like I'm going to exclude some course from the courses. So I'm going to exclude Java course from the courses. So let's see how to write the condition for that. So I'm going to say not java dot equals, and here I'm going to pass a course. Okay, and that's it. And once I exclude this course, I'm going to just iterate over a stream and I'm going to print courses to the console. So let's use for each method, and inside that let's write a lambda syntax and let's print out the courses to the console like this. It's pretty simple, right? So what we have done, we have converted set into stream, and we have used filter method to apply some condition like this. We have excluded course from the courses, and then we just use a for each method to iterate over a stream, and we have printed courses to the console like this. Okay, so let's go ahead and let's run this program and let us see the output. So look at here, the output Java is excluded from the courses list. Okay, all right, so these are the 5 different ways to iterate over a HashSet. So let me recap one more time. So we have used enhanced for loop to iterate over a HashSet. We have used basic loop with iterator, and we have used while loop with iterator, and we have used Java 8 for each method with lambda expression, and we have used Java Stream API with for each method with lambda expression. Alright, so these are the 5 ways to iterate over a HashSet. Let's discuss map interface and its implementation class, that is HashMap class. Well, map is an interface and it contains key value pair. So we have seen the different collection class interfaces, right? Collection interface, list interface, set interface, alright, and these are the interfaces who contains only values, but map contains key value pair. Okay, alright, now map interface has different implementation classes, that is hash table, linked hash map, HashMap, and tree map. So HashMap is a very important implementation class of map interface, and HashMap is frequently used implementation class of map interface. Now let's take the important key points about HashMap first, and then we'll create an example to understand more about HashMap and its methods. Alright, so here are the key points about HashMap class. HashMap is a hash table based implementation of map interface. Okay, HashMap is a hash table based implementation, and HashMap cannot contain duplicate keys. Okay, just remember, HashMap cannot contain duplicate keys. The keys should be unique in HashMap. And Java HashMap allows null values and null key. So only one, it allows only one null key and values. Alright, HashMap is unordered collection. As I already mentioned, HashMap doesn't maintain any insertion order. It means it does not guarantee any specific order of elements. And HashMap is not thread safe. Okay, if you want to use HashMap in multi-threaded environment, then you should explicitly synchronize this class. Now let's understand more about HashMap with examples. Okay, let's jump into Eclipse IDE and let's create examples to understand HashMap and its important methods. Okay, so let's jump into Eclipse IDE, and here we have created Java Collections Framework project, and we have used this project as a workspace for this course. And let me quickly create a package for HashMap. Let's name it as HashMap. So we are going to create all the examples within a HashMap package. Let me quickly create a class in a HashMap package. And let's give class name as create HashMap example. Hit enter, and let's quickly create a main method. Now we're going to create an instance of HashMap. So here I'm going to use a map interface as a reference type, and let's define a key value pair type here. So the type of the key is string and type of the value is integer. So this is the example to map numbers, okay, numbers to string. And let's give reference variable name as number mapping, and we are going to use HashMap as an implementation class of map interface. So we can remove the type here, key value type here, because compiler will automatically recognize key value type by looking into the map interface key value type. Okay, great. Now let's see how to add key value pair to map. Okay, now let's go ahead and let's use put method. So we use put method to add a new entry or a key value pair to HashMap. So go ahead and just use put method here, and the key is 1 as a string because the type is string and value should be integer, that is 1. Let's say 1, and let's add one more key value pair, 2 as a string and 2 as an integer, and let's add one more key value pair, that is 3. Similarly, let's add 2 more entries, 4 and 5. Okay, great. Okay, now what we're going to do is we're going to simply put the sys out here and just print the map. Okay, so let me quickly run the program and let me show you the output. So look at here, this is the output, and you can see key value pair. Great. And we can store one null key in a hash map. For example, let me add one null key here and value let's say 6, and let's run the program, and you can able to see here the output null. Okay, we can add only one null key. If you try to add one more null key, then it will basically replace the existing existing key. For example, let me run the program, and here you can see it just replace the existing entry. If key is already exist in a map, it will basically replace that existing key value pair. So that is what we are seeing in output. Okay, great. All right, let's see some important methods of HashMap. Okay, so how to check if HashMap is empty or not? So in order to check whether a HashMap is empty or not, we can use its isEmpty method. Okay, so let's see how to do it. Let me put out a sys out here, and number mapping, and just call isEmpty method. So we use isEmpty method to check whether a map contains any key value or not. Okay, just read the Java doc here. This method returns if this map contains no key value mappings. For example, let me run the program and let's see the output. Okay, great. It returns false because map contains key value pair, right? Okay. How to find the size of the hash map? So again, HashMap has a method called size. You can use size method to find size of the hash map. So just remember, we can find the size of the hash map by using size method. So let me run the program and let's see the output. And there we go. The size is 6. Okay, 1 2 3 4 5 6. So we have provided 2 entries for same key, that is null, that's why it shows 6. Okay, let me delete one entry, and if I run the program, you can able to see 6. The size of the hash map is 6 again. Okay, great. Now let's see how to check if a key exists in a hash map. For example, this is the hash map and these are the key value pair, right? Now I want to know whether 4 as a key is exist in a hash map or not. So in order to check if key exists in a hash map or not, we can use contains key method. Let me add a condition here. Because contains key method returns boolean value, so we can use if condition here. Let's say number mapping dot contains key, and we are going to check whether 4 keys exist in a hash map or not. If it exists, then we simply print exist, else we print not exist. Okay, so let me run the program and let me show you the output, and there we go. So 4 as a key exists in a hash map, that's why it printed exist. Okay, this contains key basically returns a boolean, and it returns true if this key is exist in a hash map. Now we understood that how to check if key is exist in a hash map. What about value? Okay, let's see how to check if value exists in a hash map. So for that, I'm going to use again if condition here, and HashMap basically provides a method called contains value. So we can use contains value method to check whether a value exists in a hash map or not. So I'm going to just provide a value as a 4 here. So 4 as a value exists in a hash map. So just I'm going to print the sys out here just to demonstrate. If 4 as a value exists in a hash map, then it just prints exist, otherwise not exist. Let me run the program and let me show the output, and there we go. It prints exist because the 4 value is present in a hash map. Okay, perfect. Now I want to get particular value by just using key. Okay, this is the hash map and these are the key value pair, right? And I just want to get a value 1 by using this key. So how to do that? Let me just add a comment here, get value by key. Okay, so let me just declare one integer variable here. Let's say v1 equals to, and this is the map, and it has a get method. Okay, we can use a get method to get a value by key. Okay, I'm just going to pass key to this get method and I can able to get the value. So let me just print here v1 and let me run the program and let me show you the output, and there we go. We just passed a key and we get a value, its value. Okay, just remember these important methods: get, contains value, contains key. Okay, size is empty, put. Okay, great. Now let's see how to remove a key value pair from the hash map. How to remove keys from HashMap. Well, HashMap has a remove method. Okay, we can use a remove method to remove key value pair. For example, I'm just going to call number mapping object here, and it has a remove method. So look at here, there are different remove methods. Like first remove method is used to remove the key, second remove method is used to remove specific entry that contains key value pair. So I'm going to use the first method and just pass key, that is 1, and after removing this key I'm just going to print the map, that is number mapping map, and I'm just going to run the program, and there we go. You can see here one key value pair is removed from the hash map. You can see 4, 5, 2, 3, you don't see 1 because it is removed. Okay, just use a remove method to remove key value pair from the hash map. Now let's create one more example to retrieve only keys and values from the hash map. So some of the use cases, like if I want to only retrieve keys from the map, okay, not values, I want to retrieve only keys like 1, 2, 3, 4, 5. So how to do it? So let me show you how to do it. Get only keys from HashMap. Well, HashMap provides a method, that is key set method. Okay, let me quickly show you. Just call key set method, and this key set method returns a set of keys. Okay, got it? So just call key set method here so that you can get all the keys in a set. Alright, so I'm going to store all the keys in a set of string. Okay, let's say keys. Now I'm going to print keys here, and if I run the program, and we can able to see the output. Okay, 4, 5, 2, 3, null. So these are the keys. Okay, so whenever you want to retrieve only keys, then you can use key set method. Alright, great. Let's say if you want to retrieve only values, not keys. Okay, so this is a hash map, it has a key value pair, and if you want to retrieve only values, not keys, then HashMap has one more method called values. So let me quickly demonstrate that. Number mapping dot call values here. So values method returns a collection of values. So look at here, collection. So values can be duplicate, right? That's the reason the return type is collection. But keys are not duplicate. That's why key set method returns a set, because set contains unique values, right? That's why it returns set. Okay, great. Now I'm going to use here collection, and the values are in integer, so let's say values. Pretty simple, isn't it? And I'm going to print the values. Okay, so let's go ahead and let's simply run the program and let's see the output. Yeah, there we go. Only values we can able to see in a collection. So this is a collection of values. So whenever you want to retrieve only values, then you can go ahead and you can use values method. Now we will see how to iterate over a hash map. So there are different ways to iterate over a hash map, and we'll see few of them. Okay, so let me quickly write the comment here. Different ways to iterate over hash map. So first we'll see how to iterate over a hash map using simple for each method. Okay, so you just use a for here, and here I'm going to use entry. So map has a entry interface, just call it and just pass type of the key value pair here, string and integer. So this is basically an entry in a map. So just remember, this is a entry in a hash map. Okay, and just let's say entry, and we are going to get a entry from HashMap. So let's call it here number mapping object and then call entry set. Okay, so entry set basically returns a set of entries. An entry contains key value pair. Now I'm going to simply print here a key. So entry method has get key. Okay, let's say value. So entry has a method called get value. So in this way we can get a key value pair, or in this way we can iterate over a map or a hash map using simple for each method. We just call entry set method and it returns a set of entries, and we can get a key value from each entry. So let me simply run the program and let me show you the output. So there we go, key null value 7, key 5 value 5. Okay, similarly for 4, 2 and 3. So this is the simple approach to iterate over a hash map. Now let's see second approach using iterator. So entry set method returns a set of entries, and set has a iterator method, so we can use that iterator method to iterate over entries. Let me just simply call here a set, and I'm going to pass this entry as a type here, and let's say entries, and this is a number mapping object, that is HashMap object, and just call entry set. And now we got a set of entries. So set has a iterator method, so let's call its iterator method, and let's store the result of iterator method here, iterator, and the type is entry, and let's call it as iterator. Okay, and we're gonna use a while loop to iterate over entries here. Let's say iterator dot has next, and then let's say map dot entry and string and then value. Let's say entry equals to iterator, and then call its next method to get a next entry. So value should be an integer, right? Okay, great. Now once we have an entry, then we can call its get key and get value method here. So in order to do that, I'm going to simply put a sys out here. Let's say key. We can get a key from the entry by using get key method. Okay, after that we have a value. We can get a value by using get value method. It's pretty simple, right? So this is how we iterate over hash map using iterator. Let me run the program and let me show you the output. There we go. Okay, we can able to iterate over hash map using iterator. Now let's see how to iterate hash map using Java 8 for each method. It's pretty simple. So let me call a for each method. So look at here, HashMap provides for each method, and it has by consumer adds a functional interface, and we are going to use a lambda expression to implement this functional interface. So here let me just pass a key value pair to this function. Key is something like that, and value. All right, Okay, and this is the syntax of lambda expression, and here we need to close, and here we are going to print a key. Okay, and similarly let's print a value. So k should be cap and value, and this is the value. It's pretty simple, isn't it? We just call the for each method, and we need to pass key value here, and we just print key value like this. Let me simply run the program and let me show you the output, and there we go. Key value. Okay, so this is a key and this is a value. Value is 7, key is 5, key is 5, value is 5, key is 4 in a string, and value 4 in an integer. Pretty simple. Alright, so these are different ways to iterate over HashMap. There may be other ways you can use to iterate over HashMap, but these are the commonly used methods. Now let me show you how to add user defined objects to HashMap. For that I am going to create one class here, and I am going to name it as student, and let me create two instance variables like string first name and private string last name. Okay, let me quickly create a constructor. Okay, now we are going to store student object in a HashMap. So student is a user defined class, and we are going to store user defined objects in a HashMap. For that I am going to create a new class here, and let's give class name as HashMap user defined example, something like that, and just you call a main method here, and let's create HashMap. So I'm going to use map as a reference type. So here we are going to use integer as a key and value as student object, and let's say map, or let's say student map equals to new and then HashMap. Okay, now we are going to add a student to the student map. Student dot, we're going to use integer 1 as a key and value as new student, and we're going to use constructor to define first name and last name here, Ramesh, and value as Padatari. Okay, let's add a few more students to the map. Value 2, key 2, and value as a student object. First name, let's say Tony, last name, let's say Stark. Now let's go and let's add one more student, and key is integer and value is object of the student, let's say Umesh, last name Fadtari, and let's see, put a sys out here to print the student map. That's it, and just go ahead and run the program, and there we go. So it is printed in some hash code. So let me quickly use here values method, and I'm going to use here toString method. Let me create a toString method in this class so that we can able to see the student object. Okay, and go back to our class, and here just I'm going to run the program now, and you can able to see here first name, last name, and here first name, last name. Okay, so this is how we use user defined object in a map. So this is the use case. Whenever we develop a real-time project, then you use basically user defined object stored in a HashMap. Alright, this is pretty much about HashMap. So just remember, these are the few important methods that I have showed you how to use in your projects. All right, we understood whole collections framework important classes, that is collection interface, list interface, set interface, and linked list, ArrayList and HashSet and HashMap. So these are the frequently and commonly used interfaces and classes. Okay, and yeah, so maybe I will create a one more course to cover all the advanced collection framework classes. All right, great. I hope you enjoyed this course, and yeah, so if you find this course useful, subscribe to my YouTube channel so that I will keep on creating such free courses for you guys. All right, thanks for watching. I will see you in the next video.